Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill in mathematics. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in mathematics. In this video tutorial, we will discuss 4 problems on maximum and minimum values of a function. The questions are as follows. Question 1. Find the maximum profit that a company can make if the profit function is given by fx is equal to 41 minus 24x minus 18x squared. Question 2. Find the maximum value and the minimum value of the function fx is equal to 3x to the power 4 minus 8x cubed plus 12x squared minus 48x plus 25 in the closed interval 0-3. Question 3. Find two positive numbers x and y such that their sum is 35 and the product x square into y to the power 5 is maximum. Question 4. A rectangular sheet of tin of size 45 centimeters by 24 centimeters is to be made into a box without a top by cutting off square pieces from each corner and then folding up the flaps. What should be the side of each square such that the volume of the box is maximum? Before proceeding to solve the problems, let us recall the related concepts. Consider the graph of a function fx in the open interval ab as shown in the figure. It can be seen that the function has a maximum value at b where x is equal to c1 and a minimum at e where x is equal to c2. We observe that the tangents to the curve at both b and e are parallel to the x-axis, which implies that f dash x is equal to 0 at these points. These are the critical points to be examined. First, for the maximum at b, consider 2 points A and C on the left and right of b and close to it. We observe that slope of the tangent at A is positive and that at C is negative, which implies that f dash x changes sign from positive to negative as we move across the point B. Therefore, change in the value of f dash x is negative, which implies that d by dx of f dash x is negative or f double dash x is negative at x is equal to c1. Hence, we conclude that we get a maximum at x is equal to c1 if f dash c1 is equal to 0 and f double dash c1 is less than 0. Now, for the minimum at E, consider 2 points D and F on the left and right of E and close to it. We observe that the slope of the tangent at D is negative and that at F is positive, which implies that f dash x changes sign from negative to positive as we move across the point E. Therefore, change in the value of f dash x is positive, which implies that d by dx of f dash x is positive or f double dash x is positive at x is equal to c2. Hence, we conclude that we get a minimum at x is equal to c2 if f dash c2 is equal to 0 and f double dash c2 is greater than 0. The maximum and minimum discussed here are called the local maximum and minimum. Hence, the values of the function at x is equal to c1 and x is equal to c2, which are f of c1 and f of c2, are the local maximum and minimum values of fx. When we are required to find the absolute maximum and minimum values of a function in a closed interval ab, the function is defined at x is equal to a and x is equal to b. Therefore, we find the values of f of c1, f of c2, f of a and f of b. Then the maximum of these values gives the absolute maximum value and the minimum of these values gives the absolute minimum value of fx in the given closed interval. Now we are in a position to solve the problems in the question using these concepts. In the first question, the given profit function is fx is equal to 41 minus 24x minus 18x squared. In the first step, we differentiate the function twice, which gives f dash x is equal to minus 24 minus 36x and f double dash x is equal to minus 36. In the second step, we solve the equation f dash x is equal to 0 to get the critical point x is equal to minus 2 by 3. We observe that f double dash x is equal to minus 36, which is independent of x. Since f double dash is less than 0, we get a maximum at x is equal to minus 2 by 3. In the third step, we find the maximum value of the function, which is f of minus 2 by 3, which is equal to 49. Therefore, the maximum profit of the company is 49 units, which is the answer to question 1. In the second question, the given function is fx is equal to 3x to the power 4 minus 8x cube plus 12x square minus 48x plus 25. In the first step, we differentiate the function twice, which gives f dash x is equal to 12 into x square plus 2 into x minus 2 and f double dash x is equal to 36x square minus 48x plus 24. In the second step, we solve the equation f dash x is equal to 0 to get x square plus 2 is equal to 0, which has no solution, and x minus 2 is equal to 0, which gives x is equal to 2, which is the only critical point. In the third step, we evaluate f double dash 2, which is equal to 72. Since it is positive, we have a local minimum at x is equal to 2. Since the given interval 0, 3 is a closed interval, we need to find the values of the function at x is equal to 0, x is equal to 2 and x is equal to 3. In the fourth step, we find the values of f0, which is equal to 25, f2 is equal to minus 39 and f3 is equal to 16. In the fifth step, we find the absolute maximum value of fx is equal to 25 and the absolute minimum value is minus 39, which is the answer to question 2. In the third question, we are required to find two numbers x and y such that x plus y is equal to 35 and the product x square into y to the power 5 is maximum. Since y has a higher power, it is convenient to express the product in y. Therefore, we put x is equal to 35 minus y in the product. Therefore, in the first step, we define the product as Fy is equal to y to the power 5 into 35 minus y whole square, which is equal to y to the power 7 minus 70 y to the power 6 plus 1225 y to the power 5. In the second step, we differentiate the function which gives f dash y is equal to 7y to the power 4 into y minus 25 into y minus 35, and f double dash y is equal to 42 y to the power 5 minus 2100 y to the power 4 plus 24500 y to the power 3. In the third step, we solve the equation f dash y is equal to 0, which gives y is equal to 0, y is equal to 25, and y is equal to 35. And the corresponding values of x are 35, 10, and 0. We observe that y is equal to 0 and x is equal to 35 implies that the given product is equal to 0. Also, when y is equal to 35 and x is equal to 0, the given product is equal to 0, and y is equal to 25 and x is equal to 10 implies that x square into y to the power 5 is equal to 10 square into 25 to the power 5 gives the maximum value. Therefore, we conclude that the product is maximum when x is equal to 10 and y is equal to 25, which is the answer to question 3. In the fourth question, the length and breadth of the tin sheet are 45 centimeters and 24 centimeters. Let x be the side of each square cut from the corners. When the flaps are folded, it produces a box of the following dimensions. Length is equal to 45 minus 2x, breadth is equal to 24 minus 2x, and height is equal to x. Therefore, the volume of the box is equal to x into 45 minus 2x into 24 minus 2x. Hence, we define the volume function as fx is equal to x into 45 minus 2x into 24 minus 2x, which is equal to 4x to the power 3 minus 138x square plus 1080x. In the first step, we differentiate the function which gives f dash x is equal to 12 into x minus 5 into x minus 18, and f double dash x is equal to 12 into 2x minus 23. In the second step, we solve the equation f dash x is equal to 0, which gives x is equal to 5 or x is equal to 18. But x is equal to 18 is not possible because the breadth of the box will be 24 minus 36, which is negative. In the third step, we evaluate f double dash 5, which is equal to 12 into 10 minus 23, which is negative. Therefore, x is equal to 5 gives a maximum. Therefore, the volume of the box is maximum when the side of each square is equal to 5 centimeters, which is the answer to question 4. This completes the answer to the question.